Hello, everyone. Welcome to our webinar. We'll talk today about the Ansible orchestrations. Basically, we'll take a look what is Ansible Tower, AWX, all the things and how they work. Thanks a lot for coming today. Appreciate your time. And I hope you would learn something new today, and at least we'll have some fun. A few words about ourselves. If you have already heard about our school, if you just first time joining our webinars, which we haven't run for quite a bit due to various reasons. Our company, Connect.com, so we are focusing on trainings and consulting services, and beside that, we are writing a lot about all the networking technology. So in the training service, we are focusing on the network automation. Obviously, we are talking about this today, as well as the traditional network technologies focus on the Nokia, Arista, Juniper's, and traditional vendors, as well as like Linux, Cumulus, and open source disaggregated world. From the console perspective, we are focusing again on the networking automation and the networking technologies to help our customers through there. We are quite a young company, just 2 years. We are working with some like big vendors like Nokia, Cisco, or end customer, City Fiber, Bloomberg, T-Link, and some others. So pretty much we're all over the space. And if you have any particular need, we'll be happy to see you on our trainings or as a client of our consulting services. Now, what we're going to look into today, as said, we're talking today about the Ansible Tower. We'll take a look what are all these building blocks, what is Ansible, what is Ansible Tower, what is AWX, what is the differences between them, and where all they coming together. Then we'll take a look into the architecture of the controller and generally what is that, how it is working, like what is the building blocks, what are the deployment models these days. And finally, we will take a look in general how the AWX is working, just to get some ideas and make a demo, how step by step from having the AWX installed in your live network or in your lab, what are the next steps to do just until you can start running your first playbooks. If you have any questions, feel free to post them in chat, or you could unmute yourself. We are generally quite democratic here, whatever better works for yourself. If the question is something that I know we have from the materials later, we'll just pause it for corresponding time. If it's something interesting, even if it's going left and right, really happy to discuss all the things so that you could get as much benefit from this session as you can. My name is Anton, so I'm founder of Economic.com, writing some blogs. We have a small team who are helping me with creating the training materials and running the consultancy services. So I'm not alone. However, obviously, I'm the face of this project, at least yet. Let's get started. Ansible Core, Ansible Tower, AWX, so all those various elements. So what are they? Probably we should start where the Ansible was starting itself, from something what we called Ansible Core. But before we start thinking about the Ansible Core, let's make a step back and think, what are the requirements that we have for the automation? Not necessarily network automation, any sort of IT automation. There are all the time multiple various aspects, and probably you already start thinking when you ask what is the requirements of the automation. So something, if you're working on this project or engaged in the projects, we have some scope, and that there might be multiple various things. But from our experience looking for multiple projects, for multiple customers, we saw that generally there are 4, depending from the company perspective, main key pillars. And we could even block them into categories. The first one would be functionality and the performance. Functionality means our automation should be capable to do its job, basically to automate all this stuff. Meaning automating of the networking, automating of the servers, automating of your application infrastructure, so VMs or your containers, whatever you're using, and be able to, how it said, in one mouse click, give you the whole infrastructure ready to run your application, even probably application deployed on top. Something that we often call the DevOps and so on. On the other hand, we're also speaking about that it should be quite quick, right? If we create some basic scripts, tools, whatever, and it's taken time, like ages, to deploy their infrastructure, it is a little bit, it is better still than doing manually, but if it's taken all the time, there will be a lot of the questions. So yeah, but why automation is so slow? I could have done it manually. It would be better, less errors, and so on. So all the time, these two pillars: how we can automate all the stuff and how we could do this quickly. Meaning that automation, when it is working, it's working quickly. On the other hand, we have the requirements in terms of the stability and the control. So one of the important aspects, how we could make sure that whenever we are applying the network change or infrastructure change, so adding the interfaces, IP addresses, changing the configuration, and so on, that we do not break anything. So how we could make sure that the process itself consisted of certain steps, so that we can step one by one and make sure that at each point we have a small windows on our process checking, okay, whether it is still on track or not. And in the same area, besides the stability, we have also the desired control. Basically, how we can log who has run the automation, what exactly changes was performed, whether this particular individual, or if we're speaking about the integration of the tools with some other tools, have possibility and right to do the necessary changes. So basically the whole orchestration and management framework. So if you think from those aspects, all of them obviously are very important. Depending on the company profile, some points might be more important than others. Say if you think about the financial institutes like financial banks or trading company or big service providers, for them, the control and stability would be more important than functionality and the speed. They can tolerate this without tolerating any sort of outages. For other companies, for the startups, for the companies that are developing building software, for them, more important to have the functionality and the performance, because they need to move quickly. They could tolerate some smaller outages and so on, and less keen on the control things. But in this or other, let's say, scale, all of the aspects are really important, and just the matter what would be more important. Now, thinking about these four pillars, and we'll be getting back to them through all our journey today, we could think about where the Ansible in these four coordinates, right? So first of all, the Ansible was starting back in the days from the Ansible, what is now transferred or converted into the Ansible Core. So the Ansible was created in 2000, if I'm not mistaken, 13, I believe. And just in 2000, so it is less than 10 years old. If you think about the magnitude of other tools or frameworks or programming languages existing, Python is 27-year-old, Go is 14 or 15-year-old already. So all of them are quite having some history. So Ansible is way younger. However, in this world, despite it being much younger, its popularity has grown a lot and still stays on the top. So originally it was created as Ansible. It was monolithic architecture. In 2015, the Ansible was purchased by the Red Hat. Now they have reworked a lot the architecture, created Ansible 2.0, which was re-architecture to be able to manage not only the Linux service, which is originally it was created to do, but also to be able to manage a vast majority of the components in the IT world, networking devices, any sort of networking devices, switches, routers, firewalls, load balancers, like Wi-Fi controllers and all the stuff, and also start looking into with the development of the clouds into the basically build and automation of the cloud, AWX, GCP, and other AWS, not X, GCP, and other platforms. The popularity of the Ansible was growing very, very fast. It was not the first configuration and management tool created. In the time when the Ansible was created, we already have Puppet Chef. A little bit later, the source stack had appeared, but Ansible had some key components or key, let's say, features such as being agentless without the necessity to install anything on the destination host to manage, which was a sort of like a revolution for the networking automation, where others tools such as SaltStack, for instance, require you to have their some sort of the agent installed. Then they also start thinking, okay, probably we could do without the agent, but this focus to be simple, to be user-friendly, so that user really don't need to know anything about the software development concepts, and at the same time being able to manage end servers, Linux servers, Windows hosts, networking devices, make the popularity growth of the Ansible very, very quickly. So originally it was created to solve the first two pillars, which are speed and functionality. Somewhere the last year, the Ansible, in the second part of the last year, in 2020, the Ansible has again reworked it internally quite significantly, and introduced, instead of having just an Ansible, first the keyword Ansible base, which we now know as Ansible Core. Basically what they did, Ansible, for the whole lifecycle duration of the version 2, was shipped with all the models installed internally. So, and when we were downloading the Ansible, was also downloading all the models Ansible have. Somewhere the last year, it was, again, before they moved to a new approach, more than 4,000 models. On the one hand, it gives a lot of really nice tools to manage all sorts of the infra or applications. But in the same time, if you were ever looking for the statistics of the merger request or pull request or some PRs in the GitHub, it was ever increasing. It was not decreasing because it was constantly, there is a bug, I would like to have new feature, and so on and so forth. And as all these 4,000 blocks were required to be somehow tested, the Ansible team just didn't have the time to test all the time. And I saw multiple times that some models we was using from our network automation perspective, for example, the netconf model, it was working in 2.8.5, Ansible, and that stopped working in 2.9.1 and was fixed in 2.9.3, and then in 2.9.5 some others networking models were working. So basic idea, there was a lot of changes and the pulls done, and the Ansible team were just not having time to focus both on the architecture of the Ansible and its features. And what they said, okay, we will decouple, and we'll get to that point later today again. They have decoupled their core architecture, so the functionalities, executor logic, how really script is being worked, and added some very, very basic Linux functionality, such as working with the files, printing the messages, copying the file, creating the new one, doing some debug functions, running the shell commands on the Linux. So some very, very basic stuff. They call it Ansible built-in collection, and they have put it together with the core. So it's now Ansible, since version 2.10, and their actual version right now of their core block is Ansible 2.11, is only the core logic functionality and very, very tiny amount of the models, really about 50 outside of original more than 4,000. On the other hand, they have converted this model for all other models. Obviously, this is where the power from the Ansible coming from. They changed the model, how they are being distributed and maintained. They created them, they renamed them as a collections, and each collection has some maintainer now. The most interesting for themselves, like where the Ansible team, Red Hat, is making the core business, they retained with themselves, so they are putting their own efforts to maintain those collections, and all others that are also important and like adding additional value for the Red Hat, but not that interesting for them from their core business perspective, they have outsourced for the third parties. On the other hand, it made it easier for third parties to bring their own collections, because now it's not anymore needed to pass any internal review from the Ansible team from the Red Hat. It makes the entry to the market for the new startups way easier, because now you can develop your own Ansible collection, publish in the Ansible Galaxy, and then people could start using your collection, because it's one of the, when we speak these days, software or even hardware product, and someone is coming to the market and say, hey, I have a nice idea, I have a new device, or I have a new product or application, whatever. And we start thinking, okay, how we could manage it? What is your APIs? How could I interact? Do you have the Ansible model? Do you have Terraform provider? And if, like, it's sort of like tick-boxing exercise, but in the same time, if the company has all the things, it's way easier for the companies who already have some sort of the Ansible internal architecture for the automation to start using them. So this was the first step, okay? It's addressing speed and functionality. Now, the company starts thinking, and especially big companies like financial service providers, the company where the stability and orchestration and all sorts of the PCI, ISO, and other audits are playing the crucial role. Okay, this very well. We have the automation, we have the speed, but how we control all the things? How we could make sure that not everyone on their own laptops creating some script and then running and then bringing our IT infrastructure to the knees, but rather only legitimate people in a centralized way. We know who is running what. We could see each and every automation, or let's put it generally, infrastructure change attempt. We could see the results, whether it was successful, whether it was not. If not, what exactly has failed. So all this aspect, then integration with some sort of the proper framework for the authentication or authorization. So how all the things could be implemented. And this is where, obviously, as there is a requirement from the enterprise, it means the enterprises are really keen to spend some money there, right? And how this world is moving, follow the money. Same was with the Red Hat, and they start thinking, okay, we have very popular tool. In the 2019, their Ansible was the most popular configuration tool worldwide. It has beat all other providers. I still think that Ansible, I was trying when I was preparing this webinar to find any latest statistics. I'm unfortunately not able to find anything newer than 2019. I still believe that Ansible is either the most popular configuration management tool, or probably it would be the second most popular, where Terraform beats the Ansible, but Terraform beats Ansible only in particular areas, in the cloud management, into building the resources in their public or private cloud. However, the Terraform does nothing for the infrastructure. It's not its intention. And the S is where the Ansible are very strong and retaining its position. So having said that, the Ansible team and the Red Hat start thinking how we could now capitalize or leverage on their enterprises requirements for stability and control and security and logging and all these important things, retaining on our nice, popular open source product. So like we think about, probably they're even contradicting. So the commercial software and the open source, in fact, in many cases are quite complementary. And this is how the Tower has appeared. Tower basically is not a replacement on the Ansible, or in this year, so in this summer, basically in the very last release, the Ansible has renamed the Ansible Tower to be an automation controller. The Ansible is building, not the Ansible, the Red Hat is building the whole ecosystem for the automation. They have created Ansible or automation hub. They have created their own container registry. So like if you have worked with Docker containers, you know that the Docker has their own hub where you could download any public container, where we are taking all the sources to build our own containers, like Linuxes or any other base images. Then they have acquired a company called Quay, and they have created their own registry. So basically they're creating the whole ecosystem, which is obviously focused on the enterprises, but also has certain support for the open source community. Obviously, their open source things are a little bit limited, but they're still present. So the idea about the Ansible Tower or automation controller, we would use these words interchangeably, is to be actually a single pane of glass for everything. So to be a single point where all people who need to do any infrastructure change would log in, they would run all the automations through this platform. The platform would be having the centralized role-based access control to all their resources. It will log all the activities such as automation, executions, attempts, which resources are available through this platform, so that it is very easy to track who is doing what and to see how how it is really implemented. So the question from there, Anis, is the management of either single Ansible core or multiple Ansible cores? It's a very good question. I'll park it for the moment. We have a slide explaining where we're talking about this. Generally, it could be either. So it depends on the implementation model, and but we'll talk more about this a little bit later. So, and this is where like the Ansible automation controller has popped up. So I said single pane. It's containing all of their resources, inventory, any other variables that might be existing, and also it supports a lot of various integrations in the existing or new like DevOps approach being built. What do I mean by this? It's possible to interact with the tower or controller through the UI or through the API. So basically, we can go and log in and manually, like with a box, clicking, ticking, whatever exercise, to provide the parameters to run our playbooks and the results. In the same way, we could do it through the API. So we could, from another application, trigger the tower to do some job, and then to receive the results, whether the job was successful or not. So Ansible Core is what is doing the job. It's not going anywhere. It is there. Ansible Tower is something that is controlling our core and basically providing the controlled access to the core to say who can run which playbooks, upon which resources, how we can access to all the details. So this is what we are having inside the tower. Tower is pure commercial product. The prices obviously rise on the relationship between the company and their vendor, but between the customer and the Red Hat. So, but generally prices, like on many software products, are quite significant. So, further Red Hat team start thinking, okay, Tower on our automation controller is a commercial product, quite inexpensive. How we can buy in people, how we can promote our product so that people start using and understanding how the tower, how the automation controller is working. And this is how AWX popped up. So AWX originally stands for the Ansible Web something. I don't know for the X stands for, probably execution or something like that. But the idea is that it was a front end. At the current stage, we could compare the Ansible controller on Ansible Tower and then the AWX in the following way. So Tower or controller is a stable version, quite heavily tested, having a stable feature, but not having all newest features. It is available for both. So it is available as a commercial option only. So you need to purchase a license and the support. On the other hand, if anything is going wrong, the Ansible team would support your software. Would create for you the patch, or will jump on call with you and fix some issues. And it has also some advanced enterprise features such as integration with APIs or integration with the LDAP or Kerberos for the centralized like single sign-on and other things, again, which enterprises quite likes, and also like high availability in other components. Those advanced enterprise features are not available on the AWX. So AWX, what their Red Hat says, it's an upstream version of the controller. Upstream version means that it's something what is pre-released for the controller. So something that is generally having newest feature, but in the same time, AWX, this is something where all those features are being tested. And if they were successful tests, if there are no bugs, and in the same time, if the community receives well the features and start using and like them, those are highly likely would appear in the controller. If the feature didn't shoot, I mean, if it was not really that interesting, probably they will drop further development. So you can think about probably upstream of the controller, and it is Red Hat is testing some features there, means it is not really production ready. Well, this is what the Ansible team says. So they say the AWX. If we think from that perspective, this is supposed to be not production ready or not production available, let's think about the Linux distributives. So we have Red Hat Linux, which is again, same company, Red Hat, commercial, popular. And on the other hand, it is quite expensive. And there are distributives such as Fedora, which is effectively the upstream of the Red Hat. Some people say that Fedora is buggy because it is upstream. In the same time, there are some products, for example, Arista, which is using the Fedora underneath. So it really depends how we treat what upstream means. So I know the company who are using AWX in production. They're quite happy about this, quite stable. So really depends how we are positioning this open source. Very popular thing across small businesses or medium business, which are not that big to pay their enterprise licenses. On the other hand, they are very happy to benefit all the advantages of AWX, yet accepting that sometimes might be a risk that some features are not working, or after the AWX upgrade, we might face some issues. Upgrade of the AWX is relatively often, so let's say once each 2 months, they're issuing new releases with some new features or some features being fixed, which is sometimes changing UI and other things, whereas a controller is more conservative. So in our presentation, we'll focus on the AWX and how we can use get started. So to understand how it is working, to make sure we understand that it is working really well and that it is working really how it is working basically. Right, so what are the main components of the tower? As said, generally their tower, this is the environment around the Ansible Core, which allows us to interact with the Ansible Core in the controlled and monitored and all other ways. I mentioned already earlier that the tower or automation controller supports both UI and API integrations. UI means user interface for us, for humans. This is the way how we are interacting with the tool. And if we need to do the job, let's say do any network change, we are writing, first of all, obviously the playbook, we are testing it is against how we should test it with all like CI, CD and all other stuff. And as a result, so once we have tested and then we're bringing them their working version of the playbook to our automation engine, we could all probably even use our Tower separate instance somewhere in our lab to develop automation as well. And then once we're happy, we're bringing it to production and we could execute it. When we could execute it from the UI, we could execute it from the API as well. If we are saying integrating our AWX or Tower with a GitHub or GitLab or any other tool, through the available API. And then their tower controls the access to their Ansible Core, and Ansible Core in its turn is interacting with the underlying component. This is very high level view. Let's take a little bit look a little bit closer. So what is really happening inside? So inside we have 4 major components of the tower, which is their front end, where we are interacting, where we are providing all their communications. It's based on the HTTP. So there is like standard browser. It doesn't have any nasty Flash or Java applet that you need to install with a plugin full of security issues. You just open it in the browser and you have a normal HTTP, so a web page which you are interacting with. It has also the API gateway, which is receiving the API calls. In fact, what is happening under the hood, the web front end is itself calling the API gateway, just requesting the data to be received in the format that it could be interpreted for the users rather than a pure JSON data. When we are integrating other applications, we have a pure JSON data that we are making the request in this format and also receiving from the device. We have also the local database, which is storing generally all the logs data, such as not only the logs data, all the local artifacts, such as inventory, user groups, organizations. We'll talk about all these items very soon. And those components are also playbooks for sure. Once we add some new elements through the front end or through the API, all this information stored in the database for further usage. And we have a worker, which is in fact where our Ansible is running. And depending on which models, or speaking in the language of the Ansible 2.10 and higher, where our collections are being installed, and which models out of those collections we are using. And then we could go to all the devices through whatever available interface. Speaking with the about the communication to the third party devices, could be SSH and REST API, probably two of the most popular ones. However, we have possibility from the networking specific automation, have the full support of the netconf and restconf in JNMI, basically all the protocols existing this way in the communication world. Right, so this is a closer look. So this is how the Ansible is looking on the logical elements. Now, looking further, how the deployment of the Ansible might be looking like. So the deployment of the Ansible Tower generally consists, so generally have two approaches. Either we take a bare metal server, it must run some Linux. We'll talk in a few moments about the requirements, but we take the platform, we install the corresponding operating system in there, which is Ubuntu or CentOS, or as Ansible team recommends, Red Hat, and install all the components there. Or cloud deployment, where we install all the components as containers. Back in the days, Ansible supported the way of the installation containers through the Docker Compose without any extra complexity of the orchestrator. They have dropped this option, so we can install only legacy Docker. We can install only legacy version. By legacy, I mean at least 1 year old of the AWX using the Docker Compose directly. All the newer releases done in this year available only through the orchestrator, either Kubernetes, which is obviously the most popular Docker orchestrator or container orchestrator these days, or the OpenShift. What Red Hat says for the container, for the production deployment, they recommend to use OpenShift because it is another Red Hat product. However, being the orchestrator, I mean, it's not mandatory. You could use a Kubernetes, and Kubernetes is really provides a lot of power, and it's way easier to deploy and manage infrastructure with the Kubernetes rather than OpenShift, given again it is an open source. So now from the items internally, what we have a container called AWX Web. I will show it the containers to you. So this is where we have our front end. So it is implemented using the Nginx, which is one of the most popular they are open source web server these days, and UV or WSGI. So basically, their web service gateway interface where the APIs are terminated and where the APIs gain points are triggered. We have also there another container where we have their core logic of their whole this application, which is called AWX task. Which is running Python and Python various applications internally. So like many applications created for the web-based, there are certain frameworks, Flask, Django, FastAPI, which is implementing the backend of the server. So AWX is using some of these frameworks under the hood to do all the heavy lifting, all the operations with what you're asking through the UI or through the backend. We have a separate container AWX EE, which is called execution environment. This is where our Ansible lives. So basically, when we are triggering something in the very simplistic form through the UI, we're pushing some request to the task container, task doing its necessary job and it's triggering the AWX to execute some job. So I'll talk about AWX execution environment a little bit more, because this is linking back to the question that Anis was asking earlier today about whether we manage one or multiple Ansible cores. So, I mean, jumping a little bit the gun, we can have a multiple cores. Each of the Ansible core would have its own execution environment, technically its own container with a corresponding Ansible version or version of, so Ansible version and dependencies installed together with that. As many, let's say, successful web application, it has a Postgres database. A lot of the application using PostgreSQL these days, for example, Netbox is also using Postgre. And they have also a cache, which is implemented as a Redis, again, in-memory database to store the data, which is reducing the necessity to interact with the PostgreSQL only for accessing some data, which is don't have to be immediately reachable. So this is at the high level, how, or already on a quite detailed level, how their architecture is working. What is execution environment? So execution environment is generally the heart of the execution of your playbooks. So this is something that is running the job. I already mentioned a little bit earlier today that in the version 2.10 and newer, the Ansible has split what we had previously known as Ansible into Ansible Core and their collections, which is in fact their corresponding Python models and playbooks and roles and documentation that you could install separately on a need basis. Why this is important? By default, the execution environment that is existing inside the AWX, by the way, how it is distributed, doesn't have any models installed at all. So basically, it means it is existing, but it's not particularly useful because you could run only the tiny amount of their tasks. At the same time, you can create your own execution environment where you would install probably all the dependencies or probably only dependencies that you might be interested from your way. And then from the AWX, you would be able to choose in which execution environment you could run the playbook in. And in this case, we are coming that it might be one or multiple different containers, each having internally same or different versions of the Ansible with same, again, or different collections installed as a dependency, and therefore, in this case, the tower is controlling multiple Ansible cores in separated containers. We were doing a big webinar about the Ansible 2.9 to 2.10 transition. All the things what I mentioned today, we will discuss more in depth in the previous one. So if you're interested, it is published on our YouTube channel, so you could look at if you haven't looked that yet. So from the system requirements, it is not that hungry, at least that they say. However, obviously, it depends on how actively you're using the AWX. So generally, what Red Hat recommends, you should have more or less new operating systems such as Red Hat Linux 7 or 8 or CentOS 7 or 8. However, I do not include CentOS 8 in here because, as you know, its support will be officially withdrawn by the end of this year. CentOS 7 will be supported till the mid of 2023, so we technically have 2 more years to live with CentOS 7. Then we have Ubuntu. It's possible to run AWX, so despite it is completely different Linux flavor, especially if you're speaking about the containerized version, it's possible to run it in there. We have at least 4 gig, we should have at least 4 gig RAM. And again, it solely depends on how actively we are using. So if they just one user or 5 users are using them somewhere, not very often, it would be enough. If you have tens of users working constantly using the AWX, obviously you might be looking into increasing 8 or 16 or 32 gigs of the RAM, because it might be really be hampered a lot, especially if you do the API integration of the Tower with some third-party things. 2 cores, don't specify which, but obviously something more or less having enough CPUs, and they specify that it should be a physical cores rather than virtual one. So be aware about that. At least 20 gig of the memory of the disk space, like HDD or beta SSD, is recommended. This is excluding the Postgres database. So I saw the calculations in the official documentation where they mean if you have about like 1,000 devices you're working on, so the automation, you need to have around 150 gig drive to store all the necessary data, to store data about all the playbooks, inventories, and all other elements. So therefore, real disk space would depend on how big your network is. And this is something that you should foresee that could be quite a huge one. It depends on the PostgreSQL version 10 plus. If we speak about the containerized deployment, Postgres, the corresponding version of the Postgres will be automatically installed when you are doing the installation of the AWX. If you are installing on the plain Linux, you need to have the Postgres installed beforehand. Right, and I said it could run either in the native Linux or in the Docker Kubernetes environment. Now, if you think that, well, I don't know anything yet about the Kubernetes, despite probably I want to learn, or even I don't want to learn at all, there is a good news. You don't need to have basically any knowledge about the Kubernetes in order to be able to run the AWX. There is a Kubernetes sandbox, which is existing for the developers or for the people who are just doing the first steps in the Ansible, which is called Minikube. Minikube allows you to run the Kubernetes locally to your host, which could be even your VM or your server or any your instance, which is Shelby Linux in this case. And the Minikube just requires as a prerequisite to have Docker installed. If you have Docker installed and you run Minikube, it's fine. You just deploy in the environment on top of Minikube. The AWX in the GitHub repo contains the step-by-step procedure. It should be a little bit big, but it's generally doable to go through the steps to have the AWX installed so that you can have your sandbox and start working with those environments. This is pretty much the way how we have it run now in our lab, just to skip the complexity of the Kubernetes. Being a very interesting and important thing, is a little bit orthogonal to the AWX, so we run it on Minikube. So this was a little bit, or a lot, about the infrastructure. Now, let's take a look how basically AWXs work. So before we go to how AWXs work, let me jump and let me make my screen a little bit bigger. So I would go to my Linux host, if I don't forget, obviously, the port that I need to connect to. Right, so this is a host where I have the Kubernetes with Minikube is running. So we could take a look how it is consisting from the infrastructure components. So it consists of the AWX itself, and also like depending the operator and the Postgres. So operator is used to install the Kubernetes, so not the Kubernetes, to install the AWX. Postgres is a database, and all the containers that we have are stored there internally. We'll get to some containers later, so that's why we need to know how to get info about the containers running. So to get the info about the containers running, we're using generative command kubectl get, and then we say what is the name of the port we would like to get it from, and then we say print from JSON. So it dumps quite a lot of the data, which is showing the internal structure of the whole this port. And what is important for us, it contains the specification, which is showing which containers we have running. So this way you could find that you have a Redis, what are the parameters of the containers, so which configuration files, how it was basically launched. So if you like to read more about the internal structure, what information is mapping there, and all other elements that might be useful for yourself. And then we could find the next container, which is AWX task. This is the one that I mentioned earlier, where we have the general Python executor working, where we need to work with. And we have also, I believe, the execution environment, which is the main one with the Ansible, which is doing the job. Now, let's jump to the VM itself. So I'm running it inside VM. So let me type the password. Define basically what the password is. Hard to memorize all the passwords. Okay. Copy it, and we are in. So basically, this is the AWX, and we will go now through this menu. So you see there's quite a bit of them. Something related to the administration, something related to the access, resources, jobs, dashboard. So basically, it's showing the dashboard, your starting menu, how many we have active hosts, failed inventories, and so on. And it shows some execution log. We'll basically, this is your starting menu. We don't have the stuff yet inside. So let me, in fact, clean this sync just to bring it to the clean stage. And then now it's like a version 1. At the end of like our demo, we will have some elements probably everywhere. Right. What all these elements about? Because the first time when I remember myself on the AWX, I was saying, okay, I was expecting to see some, I don't know, window where I could type my playbook content and get the execution running. Now, the interesting thing about that, you cannot view the content of any playbook from the AWX at all. You cannot open the playbook and read it. So this looks a little bit counterintuitive if we're saying about that AWX or Ansible Tower or Ansible Controller, whatever, is a key component for us to do the orchestration. However, we think a little bit further, we could figure out that, okay, probably it makes sense if we speak about the role-based access, so that the users should not be able to execute the playbook they should not be able to do. Probably they shouldn't be even be able to watch inside. So they shouldn't be able to know what the content of the playbook about. Right, so this is why from this angle, it's probably logically why we cannot read any content still, though quite annoying sometimes, require you to jump between the multiple windows. So what are our vocabulary when we speak about the AWX? The first one, and I will go through all the various panes. We have hosts. So hosts is where our inventory, the elements from our inventory, which we basically could assign some variables. You could think about this if you have worked with a traditional Ansible. For each and every Ansible run, we need to specify some inventory. An inventory might consist from the just simple ini or YAML file containing only the names of the hosts, or it could also store all the further data. In case when we work with AWX, it is split into the multiple, basically into like panes. One is general inventory, and we could allocate some variables to that, and then host, which must be associated with certain inventory. In the demo, we'll go through all the things, so you'll see how all this stuff is working. Then the next element, what we have in the Ansible vocabulary is project. So project is, in a simplistic form, the folder with your Ansible playbook or playbooks. It could be local to the device. So basically, you need to create them in copy manually inside one of the containers, or it is possible also to integrate the AWX with GitHub or GitLab, so that you don't copy anything manually inside, and you are just making the corresponding calls. You need to obviously provide the credentials, how you access the GitHub or GitLab, but then you could pull the data from that corresponding repository, store it locally. You have possibility also to refresh it all the time when you are running it, if you're interested in. Then we have the templates, and I'm a bit over jumping the credentials. I'll get to that in a few. So templates, this is the name of the playbook which is being executed. So templates require you to first specify the project, because basically template is a playbook which you choose from the project folder. And it also requires the inventory against which the playbook would be run. It also requires the credentials, which we have defined and separated. So there is a separate tab where provide all the credentials to connect to our endpoints, to network devices, servers, containers, anything. And so all together, so this is where we could start like doing some job with the playbooks once we have, changing our infrastructure, if we have defined hosts, inventory, projects, credentials, and templates. The Ansible Tower AWX supports a more complicated structure, which is called workflow. The workflow is a collection of the playbook, which might be executed in a sequential or in a tree format. Basically, Ansible has an internal built-in capability to figure out whether your playbook execution was successful or not. If you have worked with the Ansible, you know it pretty easy. If Ansible runs the playbook against particular host and it fails, it will fail for this particular host. And in the end of the playbook summary, we'll see that some host fails. So this dependency, whether the playbook has failed or anything inside playbook has failed, and would require in the corresponding flag in the end of our playbook execution. And then we decide if our playbook was successful, then run another playbook. If our playbook was not as successful, either stop or run some rollback, which is separate playbook. And all this info and then all these elements we could put into our workflow, where one playbook is executed, and probably even some variables could be converted from one playbook to another one, just making sure that all the info is properly distributed. So basically, it allows to create, if you think, more complicated chains where we have either multiple components involved, for which we have a different playbook, say playbook touching your network devices, playbook touching your firewalls or load balancers, playbook touching your servers, playbook touching probably your DNS server or your Docker or KVM thing. All of them are separated. All of them even may run against a different inventory, but all together they are like ending for you to have a full service implement. So we have also separated up the execution environment where we could create another environment. It's more quite complicated topic. It stays for like outside of our today's session, but I will just show you where you could find the default one and some ideas where to look about others. And we have also our like main dashboard and our jobs, which effectively what you have seen now is cleaning, which is the execution log, which stores all the details about the playbook runs, the result of the run, so whether it was successful or not, and also all the like Ansible CLI output details to see what exactly that was about. So starting with the environment, this is where we have our execution environment. As said, by default, only one is available, AWX E020. It was available in the version that we have, which is 19.1, which was released in the May. I believe since May, there were at least one more, if not two more AWX releases. Probably they have now a different default version, don't know. Anyway, as said, this particular has a limited functionality, so we need to create one before we was building one particularly for our today's demo. So just basically to review what you have, we could add a new environment here. However, we're not specifying the details of the environment. I will show you. Environment from the perspective of the AWX is a Docker container. So basically, we need to publish first the corresponding Docker container somewhere, which is working properly. And then that container can be downloaded and installed, and then you would have the possibility to run that environment. So the next thing, when we start building, before we start going inside the project itself, we need to create probably the framework where our users could access it. By default, the AWX have a single user, which is called admin, and which has super admin permissions to basically everything. Good for lab, looking into the more like production environment, or even in the lab where you have more than one person working, someone has more experience or let's say at least less risky to destroy the things. And therefore, you might be interested in having multiple users with multiple permissions. And the topest level of that, the Ansible has, I think, which is called organization, which is, in fact, might be related more to the departments, because the organization is an entity, something where we could map later the resources. So we could map their execution environment, we could map their inventory, we could map their project, we could map the template to an organization. We cannot map it to the teams. Teams like existing inside the organization. Then once we have at least one organization beside the default one, we could start creating the users. So the users, at the time when you create, you could specify which type of the user you are creating, whether it is an admin, whether it is a super admin, whether it is a normal user. Normal user means someone could just execute the stuff, the admin could create the stuff, and super admin create the stuff within the organization, and the super admin has access to everything at all in the AWX. So once we have the organization and users, we can start looking into building our inventory. In vast majority of the cases, the AWX require to have the local inventory. There are possibilities though to integrate it with some third-party tools such as Netbox or some other like popular databases or IPAM, DCIM systems, but that require quite a bit of the integration work on the scripting side. It's not working out of the box, unfortunately. And again, this is a reason for that, because as you remember, the AWX or Tower, this is supposed to be, Tower commercial product, and a lot of the things, they have a good documentation, well, good-ish documentation, which covers some basic blocks, but a lot of the things is more like driven by the try and error things, or talking with the community folks. In this case, as said, you can create, and even looking of having integration with some third-party, such as Netbox data sources, you would still require the thing of the inventory from the outside, which would pull and create locally the items. So either manually or through the script, you will have the inventory elements. Inventory elements allow to specify which users, which groups have the access to which organization this belongs to, and specify any variables that are inventory wide. We could create the groups if we like, or we could create just an inventory without any further group. Then once we have created inventory, we could start building the host. And the host, this is like creating the host bars entering the traditional Ansible. So we have a YAML field or JSON field. We could specify which formats we like more. And we can provide all the details that are related to the host. It is recommended not to store here in credentials, because as you see the information in the clear text format. However, some meaningful data such as IP address, type of the operating system, speaking about the network devices, or any other useful connectivity data, what would be the become method or any other things could be stored in here. We map the devices to inventory. We cannot create device without the inventory being created first, and they cannot exist outside of the inventory. Device can belong only to a single inventory. However, inside inventory, you could create, like if you were working with the Ansible, in the normal folder, there are groups as a like attribute where you could map your hosts. One host could be mapped to multiple groups. So if it is like useful for yourself, you could do the thing. So the first thing, generally, what you are doing, you are preparing there after you have sorted the access, you are building your inventory. Then you are building the credentials. So credentials, this is something used by the templates, by the project, in order to connect to the networking devices, to servers, to GitHub or GitLab, basically any sort of the information which needs to be pulled inside the execution of the script, or can be used, can be stored in the credentials. The information that you store in the credentials, the sensitive parts, such as password or SSH key or SSL certificate, it would be encrypted. So it is safe to store it here. The information, basically everything that you create through the UI, everything you create through the UI, can be also created through the API, and this stored persistently in the Postgres database that I was mentioning earlier. So this data would not be lost if you reboot your AWX container, even if it's running on the Minikube, or even if you reboot your VM or entirely your host. The data is safely stored in the Postgres database. So once, so it is like the sorting, right? First the access, second the inventories, and third is the credentials. At this stage, we can start building our project. By building, I mean we already need to have the playbooks created. So I said you cannot see the content of your playbooks from the Ansible Tower. You could see it from your whatever tool you're using. GitHub, GitLab, if you are integrating with the GitHub or GitLab, or if you're storing somewhere locally, it might be that you have just on your laptop or your VM with the VS Code and so on. Two things, as said, the simplistic form, I will show you, and we'll show you today the manual way. We need to jump to one container inside. So I'll show you how to find this container. So we are jumping inside the container. There is a predefined folder name. It's called here. I don't know if it's big enough. Varlib AWX projects we will be creating, and this is told us where the project directory is. We need to create our project directory there. We need to copy our playbooks inside if you work manually. Once this is done, then we can go inside our template, and we could then create the project create a task or create a, how we call it, template based on the corresponding project. So first we define where like our folder with the playbooks is, and then we could choose a particular playbook. One task, one job template is one playbook. As said, if you need to have more, this is about the workflows, how the workflows are working. We are choosing here the inventory, we are choosing here the credentials, we might add some extra parameters, which is you think about everything that you can type, if you like have in mind the Ansible CLI, like Ansible playbook, you provide the playbook name, and then you have a opportunity to provide a lot of other information. You could provide username, you could provide the password, so you provide like -u, like whatever you use, and then -k to ask you about the password, and then you could say -l like limit, not for the whole inventory, but only a particular host, and all other stuff. So basically all the things that you can do through the normal, to pass as an argument through the playbook, you can specify here. Again, like with all other resources, with the credentials, with the projects, with the templates as well, you can map it to a particular organization, so only members of this organization, if it is normal user or admin, would have access to. And that basically from the preparational perspective is, so once we have sorted all those elements, we can just run our playbook. To run our playbook, I think you see here there is a button as a rocket. You could run for the first time you would be running your template from the resources. Once you have run it, it will appear in the jobs. So the jobs would show their name of the playbook. It will show also like the particular ID of the run. It will show the status of the task, like you see failed, 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 failed. And once it is successful, and regardless of it is failed or successful, you could go inside for further details, so just press it inside, and it will show you the output from the Ansible CLI. So basically it shows if it was error, what was the error. So all the execution, like you see in the CLI up to this point, you will see. Again, you don't see the content of the playbook. You're working here with the names. You're working here with the output. So you could see what the playbook is doing, but you don't see what it is about. So I'll show you now this, all the things in flow, so that you see that step by step, we are going to get the first playbook or two playbook, let's see from the time perspective, built on the AWX and executed, so that you see how all the things are working. So jumping back. Going to my host, and probably I will reshare my screen so that you would see only the host, in order to have it slightly bigger. We go first to the organization, and let's create the first entry. We'll call it, let's say, our net operations. So again, the idea about this organization is somewhere we could map certain resources to. As you see, we could specify as a default execution environment, so we could have the different environment with the different collections installed per team if this is needed. Again, there might be instance with more than one service. Again, it might be added extra. In the simplest format, you need to have at least the name. Now, before going further, let we go to the users. So, and we go back to organization. Now we see that we have this org created. Going to the user, we can add one. You see the mandatory fields. So, and you see the organization is a mandatory field. That is the reason why we need first to create organization. We have a default one, organization, that we cannot delete, which basically means you have access everywhere. But despite this being okay, probably for the lab where you have only a few people working, even if you have multi-purpose lab and multiple people are working with the Ansible, it's better, or Ansible Tower, to create a dedicated organization per team. So say we're creating the user for the team, let's call it, I don't know, something like some standard name, so how we're using on the web cards and stuff in Germany. So what is the name of the user? Then we might also specify the email. However, it's not needed. Well, it's not a mandatory thing. Mandatory is a username and password. Again, this is the user which would be logged in the AWX. It's nothing to do with how you log into the devices. For that, we'll be talking about the credentials we mentioned beforehand. So this is just the user to the AWX so that he could log in. So let's create some password for the user. We have chosen the organization. You see multiple types: system administrator, system auditor, normal user, the one who could just work within their organization remit. So Max, and then, okay, the user is created. So it is belonging to the organization. We could create the teams within the organization. And again, they might have multiple teams so that user has access to it, but teams is not provide that strict level of the access or access control as organizations. So management environments, as said, or execution environments, sorry, we might have multiple. So we would need to add some environment in order we can do our playbooks. So to add our environment, I need, so this is an example of the one of the existing environment that we was creating, the custom one. So you see, we just providing the name. This is name in our case from the Docker. So I could go, and okay, now I believe need to reshare it back. Probably I could go inside here. So I don't know. So I could go to the hub docker.com. So where the by default, which is used by this AWX as well, and I could search for this one. So it shows one of the environment I was creating yesterday, the environment. So let's see what do we have. I have a demo environment. So I could copy this link and we'll create a new environment now. So we'll add a new one. Conalook.com AWX demo. Providing the image name, you could say that always pull container before running. Basically, the idea is that an execution environment could be also modified, and we are providing the policy whether the container shall be checked all the time, whether there is a newer version, or whether it is downloaded once, it's not downloaded anymore. We could also like make this execution environment available only to a particular organization, or we could share it that multiple organizations could use this environment. So saving this environment, we will use it. Now we have settled the basic setup. Now, next step would be to start looking into our components for our playbooks. Starting with the environment, let's create the inventory that would be containing our host. We have two hosts right now running. This is Arista and Nokia routers, so that way we would create our two hosts in this environment. Let's call our lab. We need to specify which organization the environment belongs to. So we're choosing our NetOps so that our users would be able to work with it. Could be mapped again to a particular instance group. We could add here some variables. So these variables, if we apply, they will be shared with the whole environment, which in their host, if there is anything you would like to share. So not necessarily like at this stage. You see, we have again possibility relative whom extra users we might want to add. So by default, all the users within the organization would be able to access the environment, but we can also like limit or add extra users to be able to access in here. Groups, if we are creating any groups of the host, if it's needed. In our case, and we have also the hosts that we can add. So once we could add hosts either from this pane when we are inside the environment, or we could go to the tab host, which is also possible. Let's add one here. So by default will be landed in the proper environment. We are adding the name. Let's say it would be US1. So this is where we need to start providing some data. So in our case, I would provide at least that our IP address is 192.168.110. And I also, at the network device, need to provide the network OS parameter. In this case, Arista US. So I'm saving this one. And now we are appearing. You see in the inventory, which inventory, and then host and which host. So we could see this data. Now I could jump now to the hosts. This environment is available here. We could disable this host if we would like. It's like we would like to disable it from being removing possibility to run their task on it. Say we are doing some maintenance, so just to prevent any further outage. Then we could add from this view as well. So we could specify, I would like to add device SR1. You see it must belong to a certain inventory. And there are no default inventory, hence we need to provide some parameters. Then Ansible host 11, Ansible network OS. So as you see, the same stuff as you folks are doing when you are working with the Ansible Core. So same things, but through the CLI. So we're adding here Nokia SRS MD. So saving this. So we have now two hosts in our inventory, both of them belonging to the same inventory. And you see there again, inventory, the jumping back belongs to a particular organization. So only users from the organization will be able to interact with this environment. Now we have created the inventory. Before we'll go further, let's jump to our credentials. And we have the default one, which we even, I believe, can delete. Yes, and we would add our credentials to interact with the devices. To interact with this device, we need to provide would be the name of the credentials. And again, it's not username. It's something, let's say, lab creds. So we could map that to a particular organization. In this case, it's not mandatory because some credentials might be shared, or we could say no, only users from this organization should have access to. We need to specify which credential type. And then you see that a lot of the things we have AWX, we have Ansible Tower, if like we would like to create a sort of credential that we could interact with other towers, so someone could interact with us. Container registry, if we need to connect GitHub or GitLab tokens, a lot of various things, OpenStack, OpenShift, network, and so on, source control. So a lot of the different things, funny enough, in order to connect to network devices, we shall not use not the network, we're using the machine. So machine is basically the credentials with which we are using or access data which we are using to connect to a particular device. So this is where you see you could specify what is our user. So I'm using the devices, I'm using the PyGen in my lab and all the demos. So I'm providing here this username and I'm providing the password. So as you see, password is encrypted. We could also provide there some SSH key, which is again might be encrypted as well. So we could store here the SSL certificate. At the bare minimum, we would have these two, or this, I mean, username and the SSH key, username and the certificate, defined this is what based on what we're using the network. And we also could have more elements. So we could have here the escalation method. Basically, if we need to, as you see, pfexec, su, or enable like a standard commands which we are using to get to enabled mode, like thinking about the network devices. When we get to Cisco or Arista, they generally appearing in the exec mode, and we need to type enable and probably provide the password to go to the privilege mode. And that's why it gives us an opportunity for us to choose what the command is, either from the list or type ourselves a new command, and provide the password for the pseudo user. So, and we could also use even different username and password for the privilege escalation. So that is needed if really our playbook allows us to change the user to get to the pseudo mode compared to what we have when we connect to this device. All the things we could specify in this data set. It is even, you cannot see them. You could, if you press this button, but generally it's encrypted, so that is fine. So you are saving this data. Now we have password choices, encrypted our credentials that we can use for our lab. Now, if you go now to the project and we try to add any of the projects, we need to choose which type, and it tells us provide a source control, which might be like a Git, but Git require us to provide, it's like link to GitHub, to GitLab, all the necessary credentials and so on, like Red Hat Insights, Remote Archive, or in the simple format, we'll take a manual. For manual, it says you need to go to the project base directory, which you cannot change here, which is var lib AWX, and you need to choose the directory. So how we do this, and you see it shows me have the local project, whatever. So before calling this one, we need to switch back to our project, right? So as said earlier, we have in our kubectl possibility to get our ports, and from that ports perspective, we have possibility to get all the name. So we need to output JSON. So this basically, I'm just looking for the particular name. Is very simple search. I need just to get this name. So this is name of the container AWS task. I need to go inside this container. So this AWS task, which is hosting this folder for ourselves, AWX lib project. And then we could create the subdirectory in this project, which we can work with. So let's jump inside. So in order to jump inside command, we're providing quite a long command. Basically, we are saying execute on this pod, on this container, bash command, having some extra parameters, having interactive with TTI emulation mode. So going inside the container, and you see now the bash. So you just land in the container, which is having the core functionality of the AWX with all the Python stuff and whatnot. So we're going to the folder var lib AWX projects, and shows me I have the folder called Conmic local project. Let me remove this. Okay, I'm creating a new one. Let me create it. Let's call it AWX demo. Going inside. I don't have any folder yet. I need to copy here at least playbook. If we are building the roles, I need to copy also then folder with the roles and so on. But you really need to have here inside only the playbook and the things related to the playbook. You shouldn't have here your host vars. You may have if you're willing to, but they will be anyway overwritten from the UI. So basically the idea that you have here only your playbook. So let's create one. I'll have something prepared. So just to copy, paste. So the playbook, which is having for us the possibility to use the Arista EOS collection, go to the Arista device, collect some output, store this output, and to put it into the debug. I mean, simple thing, but just to show you how this stuff is working. Same, I have another playbook which I will copy also now, and to add to interact with the Nokia. So now we have two playbooks. So you see one is called Interact Arista, and another Interact Nokia. So Interact Arista, Nokia. So this is to our playbooks, obviously following their structure. So once this is done, so once we have this playbook inside, we have them installed, we have them ready. We don't need to sync anything else with our UI. The UI, each and every time when we are trying to add the playbook, we go into this folder. I mean, when we are trying to add the manual project and read the content. So press add. Let's create here the AWX demo project. So inside, we will choose here the manual. It shows choose a project directory. Now you see their previous project directory is gone. Now I have AWX demo. You don't have any further details. You don't see the content of the playbooks. We could specify here which organization it belongs to. It's like effectively we have to. So now our project is ready. So now we can choose within our organization the playbooks out of that folder and run them together. This is what we are doing in our template folder, and we could add the job template. As said, we could add the template in workflow. Again, the workflow is separated, big topic, we put it aside. Go into the template, and here there's quite a bit of the fields we need to fill in. So say this is Arista tasks, show info, whatever. We're choosing basically run whether we like to run the playbook or check the playbook syntax. We are going to interact with the device, hence we are choosing the run. We are choosing the inventory, which we are using to run this playbook against. We are choosing the execution environment. If we have specified for our organization default one, the default one would be used, or we would say here, I need to run on this environment. So select, and finally, you need to specify the playbook. So again, it reads the content of the folder and it tells us, I have here two projects, Interact Arista, or two playbooks, Interact Arista and Interact Nokia. Using this one, we might provide the credentials. If you don't provide the credentials, we will have to provide them when it is launching, so just will be popped up. Otherwise, we are choosing here the one that we have just created. You see that here showed as a type machine. So this is a machine credentials. We are choosing this one. It's a corresponding type. Again, we could add extra variables, so which might be useful if we are running something like to change the config on the devices or something like that, and we are taking their local variables rather than taking from external systems through the API or whatnot. We can provide some extra argument, how many forks we would like to run it, basically how many parallel streams, whether we would like to limit execution to a particular devices. In our case, say prompt on launch. On launch, you will see what this, how detailed the output would be, what are the timeouts, and what other things. Right, we could add also possibility for the tags. So if we have any tags, we could skip the things. We could say that this playbook by default should be run with the privilege escalation. So not even at the level where we call it inside the playbook privilege escalation, but generally in the privilege escalation. Having the playbooks enabled in webhooks that we would be from the playbook, or when playbook is done, doing the webhooks and other things. And basically, I would assume, yeah, at a high level, that's it. There are some further parameters that we could provide looking forward, but this is like the basics, at least one. So we are saving this. You see, we have some further things we could add again. Who can access, if we could further restrict access, either are there any notifications that will be around this, whether we like to schedule it to run on the cron stuff, whether any jobs were run already, and whether we like to add some extra parameters to the UI element. So now once this is done, what we need to do, we need just to push our template. As we have asked to launch certain parameters on the, to provide some parameters on the launch, it's provided here. So we know that this playbook is to run against our inventory, which is consisting of Cisco and Arista devices. And obviously Arista models would not work on the Cisco device and vice versa. Hence, we would say here, run it for the device ERS1. Unfortunately, it's not doing any pop-up telling which device is available for the inventory, but at least we could type here the text. Press next. We could again provide here extra parameters, so at least we could see what the extra parameters are. And you see it added prompted variables limit, and we could press the button launch. So at this stage, a lot of things starts happening under the hood. So it's pulling the corresponding Docker container with execution environment. Then it adds a playbook inside this execution environment, and it starts running the playbook. So it's being generally refreshed. So whenever you see this line and you see the green means okay, means execution was successful. It tells our playbook consists of one play, two tasks, one host, took 15 seconds to run, and the output of their CLIs. Just let's jump back. So what our playbook was doing, so this is this playbook, it was using this model. So it had this coming from this collection, these commands, and then we was using Ansible built-in models, which is a part of the Ansible Core by default. We would like just print for us the content of the variables. This is exactly what we see in this output. We see this is a message that we are printing, show output. It starts printing the text. You see the text is a little bit truncated. So we have line 17, 8, and then 54. So the Ansible, the AWX sees that the output is long. I probably will truncate, but it gives you a possibility to read the full. So if you press on that, it is opening more detailed view, where you could go into the JSON view and see, okay, in this particular task, it was providing us that amount of lines. So it showed us this show output, change standard output, and then we see also standard output lines. We could see it's also in different format if there was any errors or so on, but in our case, all good, so it provides us JSON data. So we could validate it, or we could also like copy everything from this and put in a separate file if we need to, but basically this is how the task is logged. Now you see we have now we are now in the jobs view. So if you would go back, we'll see that this task, this template was executed when it started, when it's finished. What was the outcome? You could relaunch it again. So, or you could see the further details, I mean, either in short format, which template was it, which execution environment ran it against, which inventory, who has launched this, out of which project, and also which credentials were used. So basically all the details are available, or we could go further and read like really all details in like more detailed view. So what was the playbook name and so on. So now, in the dashboard, we would see that we have two hosts, we have one inventory, we have one project. Now I said project is a directory, so which contains all our playbook. We could go into templates and we could add another template. So let's add Nokia show info. Now we are choosing the same inventory, but we will choose a different playbook. We choose NordCam. So same credentials, or we could choose a different credentials if we wish to. We are choosing the same execution environment. And now we would just add here the SR1 directly without adding the limit as an extra step. The rest is the same. So again, you should provide a lot of further details if we need to, just saving this. And now if we go to the template, we see we have another job template, was never yet run. Pressing the launch. As we don't need to provide any further details, we haven't ticked any box like prompt on launch. It doesn't have any data, so it starts executing the playbook. So doing the job, connecting to the device, providing RR. Same story there. You see the green line means it is okay. So it was successful. Shows us the details. Again, in this case, it was not that many lines, so it's printed everything. We're seeing the recap. Now, if you see on the dashboard, we have it shows how many today was successful executions. So what we have here in jobs. Now, again, you could see the details and so on and so forth. But this is the way how the AWX works at the high level. Do you have any questions at this point or anything, please? Okay.
Each project have own folders. Yes. Can we use subfolders for sub-projects?
So generally, yes, you are correct. The idea is that each project has its own folder. You can generally, if I go in this view, let me edit the template. So it shows, so this is a text field. So if you have some project, it not necessarily will show you internal structure, but you call something like your subfolder / something, and it will accept it. So if it is existing, so you have this possibility.
Okay, thanks.
Good. So we just then have a few more things to step through. So this was a general, the main thing we would like to share. So how this is working, really quite powerful tool, and being this part of the open source is quite reliable. Also looking forward, you might need to think about how, if you bring to production, how you implement the HA and other things, which is outside of the AWX because it doesn't support that. So I said one of the key questions that was hearing multiple times from the customers for whom we were helping to deploy AWX or deploying entirely the system was how I can make sure that nothing is really can be broken, in the sense that I have my network technicians, and my network technicians shall not be able to do any network change. They should be, though, able to run some playbooks, which is collecting some operational data, and then they could look the output in the Ansible view. So, or I have a different departments. I have a servers team. I have my DevOps. I have my network engineers. Okay, they know, I think about, say, GitHub or GitLab, but everyone has their own repos, and I would make sure that each one could work on each domain, but I don't want to have 10 dedicated AWX instances. A lot of the questions around how can make sure that everyone is doing only what it's supposed to do. This is where the role-based access is coming. I'm showing in multiple times, emphasizing you can map almost everything to the organization. Once you do this mapping, like execution interfaces, execution instances, execution environments, projects, inventories, host inside the inventories, the credentials, the templates, you can create a structure that everyone would have only view to the components that he or she needs. So it creates a safe environment that safe for the technicians who are not who shall not be able to do any network change. They still could benefit from the automation, just pulling the multiple reports, producing somehow in the Jinja the output that is then printed in the output, or that is then sent to mail or to some shared folders or something. Instead of them jumping through the box and trying to collate the information manually, the Ansible is doing for themselves. So likewise for the networking engineers who should be able to change their network configuration, we would have a separated project which is including their playbooks, which particularly which can do any sort of change. Probably there will be some integration with, again, Netbox or GitLab to pull some data, some variables for the people instead of storing their variables somehow locally in the AWX. So this is all available even in the basic, I mean, in the open source setup, not even speaking about the integration of the commercials. So a lot of things about this particular tool that you could like to learn, which we was just touching. So how to integrate with the GitHub for storing the playbook instead of copying it locally, or how to integrate it that during the playbook execution, we are pulling some data from the GitHub or GitLab, how we can create the workflows where we have multiple like interdependent components, how to create your own execution environment, because I say the default one is quite limited. There are a lot of the things that you might be interested in. There are a lot of the information available on the internet, or we would be happy to see on our network automation trainings. We have two trainings which are available right now as a self-paced or as a live one, zero to hero network automation with knowledge. Both of them are starting early September, but where you could have pretty much like the same experience with me or my colleagues running the webinars and showing a lot of the demos, or self-paced, which you could start right now. Also, we are building right now the dedicated training for the AWX, which we believe will start somewhere in October, highly likely. And that training will contain only AWX from all for way greater details, starting from scratches, how to install AWX on the Kubernetes, how to create your workflows, how to do all the necessary integrations and so on, what we was briefly touching today. Questions for them are, is there any special price for the people joining this call? Well, for the zero to hero network automation training, you can join till the end of today. They still have a discounted price. We intentionally want to change in this. Looking forward, we would see. So we have the discount for the returning students. We have people who was already attending both our trainings. So therefore, just start somewhere and you will have some nice discounts somewhere. Thanks a lot really for our attention and for your questions. You could always reach us on the mail or the phone or through the web forms. We wish you all a lot of success and good luck with your automation projects. And if you need, just shout out. We are happy to assist wherever we can. Have a good evening or day or morning, and see you soon. Hopefully have a good rest of your summer. Take care. Goodbye, folks.
Thank you for useful information.